Hello everyone. In this video lesson, we solve example 1.29, 1.30 and 1.31. Okay. So you can see an activity at the top, activity 4. So it is similar to the earlier examples what we have done. Okay, you can easily fill it. Now example 1.29. Let A is equal to B, D, G, E, H and B is equal to A, E, C, H. Verify that number of A minus B is equal to number of A minus number of A intersection B. Okay. Now, in solution, as you can see, A the number of elements, B the number of elements. Now, what does number means? The elements inside the set A. Okay. So, how many elements inside set A? You can count here 1, 2, 3, 4, 5, right? And how many elements inside of B? 1, 2, 3, 4. Okay. Now, so first we find out left hand side. What is left hand side? Number of A minus B. So first find A minus B, then you have to count it, right? So what is A minus B? So A minus B, you have to take all the common elements of B from A and you have to write the uncommon elements of A. That is what we say A minus B. You see A, sorry, not in this set. B, no B, write down B. D, no D, write down D. E, already it is there. G, no G, right. H, we have already there. So you should not write the elements of B, you should write only the elements of A. Okay. Now how many elements you can see here? 3 elements. So that is number of A minus B is equal to 3. So which is named as equation number 1. Next we'll find out right hand side. What is right hand side? Number of A is equal number of A minus number of A intersection B. Okay. So already we know that what is the number of A? 5, right? Okay. Now we have to find A intersection B. What is A intersection B? The common elements between A and B, E, H. Okay. Now how many elements we have in A intersection B? 2 elements. So when you subtract this, number of A minus number of A intersection B, 5 minus 2 is equal to 3. So from 1 and 2, both are equal. So from 1 and 2 we get number of A minus B is equal to number of A minus number of A intersection B. Okay, I hope you understood the example 1.29. Let us move to example 1.30. So what is all about example 1.3? So you're going to find using Venn diagram. Okay. So in a school, all students play either hockey or cricket or both. 300 play hockey, 250 play cricket and 110 play both games. So I want you people to remember the basic formula, that is number of A union B is equal to number of A plus number of B minus number of A intersection B. So already we have learned this formula when we started this topic. Okay. Now, so that formula we are going to use in this example to solve it. Okay. So what is the question? Find the number of students who play only hockey, the number of students who play only cricket, the number of students in the school. Okay, now the basic idea, what you do, just name it first. As the descriptions you have to write, let H be the set of all students who play hockey and C be the set of all students who play cricket. Now in this Venn diagram, so as I already told you, when you draw a diagram, you just draw one circle and to the half of another first circle you have to draw another circle. So this is hockey team and this is cricket team, right? Okay. Now how many people play hockey? 300 and 250 play cricket. First you write, just Don't imagine this. Okay, okay, just let it be like this. So I'll write afresh. So now 300 play and 250 cricket. Now how many people play both? 110. Now in every sum what you do, you have to subtract this 110 from this and this 110 from 250. Okay, so that's the basic idea. So you have to subtract, if you want to find h alone, you have to find the intersection parts. Okay, and also if you want to find the c alone, you have to find subtract this intersection part from c. Then only you can find only h and only c. Only means only people who play hockey and only people who play cricket. So that's what they have done here. So number of h is equal to 300, number of c is equal to 250, and both hockey and cricket 110. Now when you subtract 300, you will get 190, and when you subtract 110 from 250, it is 140. Now how you write it? This 190 are the people who play only cricket, and this 140 are the people who play only, sorry, this 190 is only hockey, and 190 uh, is only hockey, and 140 is only cricket. Okay, now this 110 are the people who play both hockey and cricket. Okay, so using the Venn diagram, the number of students who play only hockey 190, and the number of students who play only cricket 140. The total number of students, you can add 190, 110 plus 140, altogether you will get 440. So these are the total number of students in the school. Okay, now I hope you understood this. Now another one example, example 1.31. In a party of 60 people, so there are 60 people in a party, 35 had vanilla ice cream, 30 had chocolate ice cream. All the people had at least one ice cream. Then how many of them had both vanilla and chocolate ice cream? Only vanilla ice cream, only chocolate ice cream. You see, in there are 60 people in a party, so 35 is people holding vanilla ice cream and 30 people holding chocolate ice cream. So the question is, in 60 people, all the people have either two or any one of these. Then what you have to find? You have to find how many people have both. So it's bluntly you can say that, you see, when you subtract this 30 from 35, you'll get 5. So the 5 people have both vanilla and chocolate ice cream. Okay, so in similar way, so we have 5 intersection. When you subtract this 5, you'll get 30. So 30 have vanilla and 25 have chocolate. It's very simple. So you can see here, so no need to write like this, you just write in Venn diagram. We have 35, yeah, 30. So this x is unknown, right? So we don't know. So that's why every time what we do, we subtract this x from this, right? So you have to find the x first, right? So what we do here, so listen, let number of v is equal to 35 and number of c is equal to 30. We know that vanilla and chocolate, and number of v union c, which means 60, right? Okay, which means this 60 are the people both. Now we use the formula, so no need to use this formula, don't use this. You can use the formula here. I think I can write here. Okay, so number of v union c is equal to number of v plus number of c minus number of v intersection c. Now number of v union c 60 is equal to number of v, how much? 35, number of c minus 30 minus number of v intersection c. This both people who are using both ice cream. So 60 is equal to how much we got? 65 minus number of V intersection C. In another step, what we do, we take this 65 this side, 60 minus 65 is equal to minus number of V intersection C. I think I don't have space here, so I have to delete these steps. Okay, just remember this step. Okay, now okay, 60 is equal to 65 minus number of V intersection C. Now 60 this side, when I take this side, my plus 60 becomes minus 60 minus number of V intersection C minus 5 is equal to minus number of V intersection C. So this minus will go off on both sides. We'll get number of V intersection C is equal to 5. So vanilla and ice cream, which means the people who are holding both vanilla and ice cream is 5. Okay, now we got this 5 here, so no need to use, you use the steps which I wrote now. Okay, so hence 5 people has both ice creams. Now we can use this x as 5. Now subtract this 35 minus 5, what will get 30, and 30 minus 5 you'll get 25, right? So the number of people who had only vanilla ice cream, 35 minus 6, 35 minus 5 is equal to 30. So number of people who had only chocolate ice cream, so 30 minus 6, which will get 25. Okay, okay children, so that's all for today. So we'll meet in the next video lesson and we'll solve example 1.32. Thank you, and make sure you practice the sums.